Good afternoon. We had seen one example of CRC scheme in the transmitter. We had a frame data. So based on the generator polynomial, if it was power of 5, then 5 zeros will be appended at the end. If it was of power of 4, then 4 zeros will be appended. And then we performed XOR operation. At the end, whatever is the remainder, that we will use and replace zeros by the remainder. That will be the frame which will be transmitted from transmitter to the receiver. This is having data and extra bits. Extra bits or redundant bits help us to detect the error. Is it done so far? Please open that example, and at the receiver, the same process will be followed. At the receiver, whenever the frame is received, it will follow the same process. So was it done? Did we complete that part? The verification part at the receiver? Okay, what was the remainder? Yes, if the remainder is 0, that means data is intact and everything is fine. So now everyone, the example which you are doing, in that example, please corrupt the 6th bit and then see what you are getting. Did we do this already? We have changed one of the bits. Okay, we have done the 4th bit. Fine. Let us continue with the 4th bit. If you correct the 4th bit, what is the value of 4th bit? Is it 1 or 0? Okay, then you will make it 1, 0. If it is 1, then you will make it 0. Please make it 0. Then that frame is received in receiver, and then you have done the process. Okay, I think now I recall, we were getting different answers. What is the answer which we are getting? Remainder? Okay, 1, 1, 1. So if all of you are getting remainder 1, 1, 1, wonderful. In short, non-zero remainder is achieved at the end. And when the remainder is non-zero, that means our data is problematic. So here error has been detected. So do we have any doubt in CRC? Cyclic redundancy check. Okay, fine. And there one was in self-study, parity bit using Hamming distance. I might ask in the examination from that. Please do that topic. That will not take more than half an hour, and do it from the Tenenbaum textbook. So now let us talk about something else. Okay. Now let us talk about actual data link protocols which are going to be used to send the data and to receive the data. And I hope so let us again very quickly revise how the data transfers. At the transmitter, it will be generating the user will send data to the application layer. Application layer will append a header and message will be constructed. Message will be given to the transport layer. In the transport layer, header will be inserted. Can you tell me what will be the content of transport layer header? What are the possibilities? Port address, source port address, and destination port address. Port address is 16 bits long and port address is unique on the computer. On the system, if you have 5 processes, 5 unique port addresses will be there. On the different system, port address might repeat, but on this system, each process has a unique port address. So that's how segment will be constructed, where you have source port address, destination port address, and the message which you got from the upper layer. This is known as a segment. Segment is passed on to the internet layer or the network layer. At the network layer, we are going to construct a packet. In the packet, you will be inserting the header. Can you tell me possible content of the header at the network layer? Yes. No, not port address, Abhi. Port address we have already included at the transport layer. We'll be having the IP address. IP address of the source and IP address of the destination. That is what we are going to write here. Now let us, just a second. Okay, so everyone, let us say this is IP1 and MAC1, IP2, MAC2, IP3, MAC3, IP4 and MAC4. And on all these computers at the transport layer, we have three processes. Let us say it is in port 1, port 2, port 3, port 1, port 2, port 3, port 1, port 2, port 3, and the same here. So at the network layer, what will be in source IP address? When we are constructing a packet, what will be source IP address here? I have numbered the system for you, so it will be easy for you to tell me the answer. In the header of the packet, we will be writing source port address and destination port address. Can you tell me what, source IP address and destination IP address. So can you tell me what will be the source IP address here? What will be the source IP address? What is IP address of the computer? IP1. Next one is IP2, IP3 and IP4. What is source? Source means transmitter. So what should be the IP address of the transmitter? IP1. Yes. So source IP address, you are going to write IP1. In destination IP address, what shall we write? IP4. Yes, because we are going to send data to this computer. This network layer will be sending data to this computer. And then this packet is given to the data link layer. At the data link layer, we will construct a frame. Frame means header, data, and trailer. In the trailer, like CRC might be calculated and added at the end. So there is trailer. If we are using CRC, then CRC. If you are using different mechanism, then that will be used. In the header, the possible content at the data link layer is going to be source or MAC address and destination MAC address. So what is the source MAC address here? MAC1. And destination MAC address? No, it will be MAC2. What is the scope of the data link layer? Data link layer functions between adjacent nodes. So you will be writing MAC2. If you write MAC4, then when it will be received here, then this will not accept it because it is meant for MAC4 and this is MAC2. So it will discard it. So here at the source, you are going to write MAC1 and MAC2. Then it is given to the physical layer. Physical layer is converting into bits and sending over the channel. Bits are detected at the physical layer. Then it is given to the data link layer. At the data link layer, it is checking that this is meant for MAC2. I'm MAC2. So it will check the correctness of the frame, like CRC verification at receiver will be done here. If it is correct, then header will be removed, trailer will be removed, and the remaining part, which is a packet, it will be given to the network layer. At the network layer, header will be looked into, IP header, the network layer header. It will check that this destination IP address is IP4, but I am IP2. That means this is not for me. So it will give back to the link layer. It will again give this packet to the link layer. So now packet is received at the data link layer. It will construct a frame from that. So again it will be inserting header and trailer. CRC will be done once again, and then header and trailer will be appropriately written. What will be the header? Source MAC address. What is the source MAC address now? MAC2. That is correct. MAC2 is the source MAC address. And destination hardware address, what are we going to write in that? MAC3. True. Now it will be received here MAC3. So it will accept CRC verification will be done. If everything is fine, then given to the upper layer. Otherwise, it will be rejected. At the network layer, again, IP check will be performed. If IP address matches, then it will give to the upper layer. But here we know that it will not match because it is IP3 and this particular packet is meant for IP4. So again, it will give to the data link layer. Now at the data link layer, we are going to construct a frame from the packet. We are going to write source MAC address and destination MAC address. And what will be the values of them? Yes, source MAC address will be MAC3 and destination MAC address will be MAC4. That we will write, and it will be received by this link layer. This link layer will check that okay, MAC4, so it is fine. It will check the correctness of the frame. If the frame is found to be okay, it will be passed on to the upper layer. That's the packet part of the frame. That part will be passed to the network layer. At network layer, IP address will be matched. So here, this is for IP4 and for IP4. So it will be given to the transport layer. Now at the transport layer, in source port address was whatever, port 1. And destination port address will also be port 1 or port 2 or port 3. Whatever was written. So here if three processes are running on, then it will look at the TCP header or UDP header, and it will look at the port address. Whichever port address this particular packet is targeting to that application or data will be delivered. So let me again quickly ask you, your transport layer is functional between what? What is the scope of the transport layer? No, not source and destination. When we say source and destination, we mean the computers, the systems. So our source and destination would be at which layer? No, not application layer. No, network layer. Yes, network layer. At the network layer, we realize whether this is the computer or it is to be forwarded. So here at the network layer, it will be realizing that this is the destination. So network layer is responsible for taking your data from source to the destination. Without network layer, we cannot reach the destination. So source to destination or host to host, that terminology is used at the network layer. Transport layer, as Smith said, it is true. It is end-to-end communication, like end-to-end or process-to-process communication. What is the end point? That is our application. And transport layer is taking us there. So transport layer is providing end-to-end communication. And what about link layer, data link layer? It provides which type of communication? Between adjacent nodes. But there is a word for that. Can you tell me? Yes, hop to hop or node to node delivery. It is node to node delivery or it is hop to hop delivery. So I hope this is very clear to all of you that network layer is the lowest layer at which you come to know whether this is the correct computer. At the transport layer, we know that for which process this data is meant for. And link layer takes us to the next one. Then again, this will be taking over as the host, as the source, and it will be sending data over here. then it is responsibility of this data link layer to send the data here and so on. So now we are going to learn that when we are sending data from here to here, then what care we have to take in order to deliver data successfully and correctly. Our scope is here. The same would be applied here. Once we run just between two pairs, then the same will be applied here. So if you have any doubt, feel free to ask me. How the data flows, how the data is delivered, and scope of each layer. I hope that is very clear with all of you. Are you comfortable? So now I want you to actively participate and think about this, that I have received data from the network layer that is known as a packet. So data link layer has received a packet from the network layer. Then it is constructed the checksum, calculated the checksum, and frame is to be constructed. Responsibility of the data link layer is to provide services to the network layer. From the packet, it will be constructing a frame. So in order to construct the frame, a header and a trailer will be inserted. In the trailer, parity bit or checksum or Hamming distance, or let us say CRC, whatever we are using, that will be appended. Something related to error checking is written in the trailer. In the header, we are going to write source MAC address and destination MAC address. So that is our frame. Okay. So now let us say our frame is there. So now we are going to follow a very simple mechanism. We are going to follow a very simple mechanism that a frame is sent. It is received at the receiver. So now tell me, what will receiver do? When receiver receives a frame, what is it supposed to do? Of course, your data link layer gives at the physical layer of the source. Then that is given on the communication channel. Then communication channel takes your data to the destination. Then your destination's physical layer is detecting bits. And then those bits which are detected, it will give into the data link layer. The data link layer has received a frame. In the frame, it is in header and trailer and data. Should we directly discard header and trailer, Harsh? Or we should be using them? Yes. First, we should be checking whether there is any error. When you receive the frame, you should be checking whether there is any error. So we will be verifying the data integrity. Is the frame correct? If the frame is correct, then tell me, what should you do? You have checked it and you have found that the frame is in order. It is proper. Then what should you do? We have checked. Yes, then remove the header, remove the trailer, and then if you received the correct frame, then we are removing the header and trailer. So once you remove the header and trailer, that means that is a packet. The remaining part data is a packet. So we have a packet now. So what do we do with that? No, we don't convert into bits. I mean, actually, if you think over that, everything would be in bits only. You know, everything would be in the bits only. So we don't convert into the message. That is not our job. We are at the data link layer. So this packet will be given to the network layer. That's what we will do. We will get frame from the physical layer. We will check if it is correct. If it is correct, then header and trailer will be removed, and the remaining part of the frame, which is now packet, each will be passed to the upper layer. Upper layer is network layer or internet layer. So we are passing to the upper layer. Okay. So if correct, pass on the data part to the network layer. So now there is two possibilities. Either it is correct or it is not correct. If it is not correct, then what do we do? The frame which we have received is incorrect. Then no, we are using error detection mechanisms. We are not using error correction mechanisms because error correction codes are very expensive. That I believe we have discussed already. So if it is incorrect, then we remove the frame. Then we discard the frame. So transmitter has sent the frame. We need to inform the transmitter if the frame is correct or if it is not correct. Because if it is correct, then transmitter can send the next frame. If the frame is not correct, then probably transmitter can retransmit the frame. Right? So this is how it is done. That you send the frame, then receiver is receiving the frame. If the frame is correct, then pass on the data to the upper layer and inform the transmitter. This is known as an acknowledgement. If the frame is correct, then send acknowledgement. Like when you receive the courier, then you write down the feedback. Like receipt is, you sign the receipt, and that is acknowledgement or feedback to the transmitter. So now let us again look at that. At the transmitter, frame was sent. If you get an acknowledgement, that means everything is fine. Then what you should do? You should send the next frame. If you don't receive an acknowledgement, at that point of time, whatever frame you have, the same frame should be sent again. Are we good so far? Okay. So name of this protocol is stop and wait protocol. What are we doing here? That we are constructing one frame. We are sending that frame, and then we are waiting for our data to be delivered. If the data would be delivered correctly, you will receive an acknowledgement. If you receive the acknowledgement, then fine, you will be sending the next frame. If you don't receive an acknowledgement, then the same frame which you had sent, you will be retransmitting. So now the question is, how long should we wait for the acknowledgement? So I'm just listing down the possibilities that if you want to ensure reliability, what we should do? We should have an acknowledgement. So we will know that when frame is delivered correctly and when frame is not delivered. So now you have already sent the frame and acknowledgement is not coming. So if you don't receive an acknowledgement, there could be two reasons. Can you tell me why acknowledgement would not arrive at the transmitter? Yes, first possibility is frame is incorrect. The content of the data was changed, and that is why your checksum didn't match. If checksum didn't match, that means frame is incorrect, and that is why acknowledgement will not be generated. There is one possibility. Can you think of other possibility in which acknowledgement will not come? If the frame is correct, then acknowledgements always will be sent. So first possibility is if data is incorrect, then acknowledgement will not be sent. That is one possibility. Another possibility is acknowledgement was sent, but then on the reverse link, let us say while the acknowledgement was traveling, connection breaks, or due to some network issue, acknowledgement is dropped. When I say acknowledgement, what is that? Acknowledgement is also a tiny frame. Acknowledgement from router 1 to source would be having source MAC addresses MAC 2 because it is sending and it is meant for source. So it will be MAC 1. That means it is a tiny frame which is traveling over the link. So your data can be lost over the network, it can be changed. So by chance, if your acknowledgement is dropped, then also acknowledgement is not coming. And if the data frame which you sent, the frame itself was lost, then receiver is not receiving any frame and hence no acknowledgement will be sent. So there are certain circumstances in which acknowledgement will not be sent. So in these cases, you are supposed to retransmit the data. Are we good so far? So the question is, how long should you wait before attempting the retransmission? Like acknowledgements are required, then retransmissions are required. But when should you attempt retransmission? Like after 1 hour, you send a frame. And then for 1 hour, if you don't have an acknowledgement, then you will be sending. Is it like that? So there has to be some time limit, right? You have to wait for some time limit that by that time, if acknowledgement does not arrive, then we can say now enough is enough and data has to be resent again. So that is decided by retransmission timer. After sending a frame, we start a retransmission timer. And when the timer goes off, by that time, if you don't have an acknowledgement, then you will be retransmitting the data. If you have the acknowledgement, then you will stop the retransmission timer and you will send the next frame. So what do? We send the frame at the receiver. We check whether it is correct. If it is correct, we send the acknowledgement. After sending the frame at the sender, we had started retransmission timer. So when the acknowledgement is received, retransmission timer will be stopped and the next frame will be sent. If acknowledgement does not arrive because the frame was incorrect, then the same frame will be transmitted again. So now Preeti is asking that what if acknowledgement is lost? So can you tell me, Preeti, now what will happen? Here acknowledgement was sent, it is lost. That means here after some time we will have a timeout. So whenever there is a timeout, then we are going to send the next frame again. So let us say you had sent ABC. Your frame was ABC, which was correctly received by the receiver, which was correct. So what have we done? We have sent ABC to network layer. And apart from that, acknowledgement was generated. Now, this acknowledgement which was generated is lost due to some reason. So whenever acknowledgement is generated, there will be a timeout, which is known as retransmission timeout. So whenever there is a retransmission timeout, what will source do? It will again send the same frame. So retransmission will be attempted. ABC will be sent again. So should you accept this frame now at the receiver? ABC was the frame which was correct. It was sent, it was received, then it was passed to the player, acknowledgement was sent, acknowledgement is lost. So there is a timeout. Whenever there is a timeout, the same frame is sent again. So should receiver be accepting this frame again? No. Because if it receives that, then we have duplicate data. Of course, it will verify that whether this is correct frame, but the frame is correct. And by looking at the content, we cannot say it is a duplicate frame. Because when you are chatting, you might be rating high, then again you might be rating high. So when receiver is receiving high 2 times, that does not tell necessarily that the frame is duplicated frame. That could be fresh content. That means whether the frame is duplicate frame or it is a fresh frame, that can never be decided by looking at the data itself. Do you agree to that point? So now, If we do nothing else, then we will give the same frame again to the network layer. So what do we do? Of course, whenever you receive the correct frame, you will send the acknowledgement that I have received it. Okay. So now there is something called sequence number. We number of frames, frame number or sequence number. So we send it as 1. If it is correct, the acknowledgement is generated. When we transmit, we again say it is 1. So it knows that, okay, I had received 1. So I'm waiting for frame number 2 actually. If I'm again receiving 1, that means there was something wrong. That is why it is giving me. So what will we do? We will know that it is a duplicate data and hence it will not be delivered to the network layer. We will not deliver it to the network layer because we have detected it to be duplicated data based on the sequence number. And acknowledgement will be generated. We will say that yes, I have that frame. So hopefully this time we will get the acknowledgement. When you receive the acknowledgement, then timer will be stopped and next one will be sent. So frame number 2, if the content data is XYZ, then it will be sent. The content could be ABC itself. The content could be repeat content. Like you want to send ABC, but then if it is 2, frame number 2, then receiver will accept that because it knows that I have received frame number 1 and now this is frame number 2. So this is a fresh frame. So we need a sequence number to differentiate between duplicate data and the fresh data in case of retransmissions. In stop and wait protocol, we send only 1 frame at a time. It is also known as only 1 frame is outstanding at a time. Means you are sending outstanding means without acknowledgement, unacknowledged. You are sending a frame. If it is not acknowledged, you are never going to send another frame until then. Once you receive acknowledgement of that, then only next frame will be sent. So now again, they are getting data from the network layer. They are constructing a frame. So in the frame, we are having checksum. Checksum means something related to error detection in the trailer. And in the header, we have MAC addresses. And apart from MAC addresses, we have sequence number also. In the header, we have sequence number. So the sequence number is extra information which is part of the header, not part of the data. We don't want to deliver 1, but 1 helps us to deliver our data correctly. Is it clear so far? Feel free to ask me at any point of time. Whenever you have any doubt, please ask me, because stop and wait is the simplest version. Then we have subsequent protocols. So if this is clear, the other job should be easy for us. Okay. So now everyone listen to the question carefully. We are writing sequence number not to sequence the frames because we are never sending more than 1 frame. If in your protocol you are sending 5 frames together, then of course you don't need to number them like this is the first frame, second frame, third frame, fourth frame and fifth frame. Because if you send multiple frames, then you need to tell your transmitter that this is the order in which they were sent. However, here you are sending only 1 frame. So sequence number is not used for the purpose of sequencing the frames, but it is used so that your receiver knows that what has been received so far and what it is expecting next. So now 1 frame is sent. My question is, should acknowledgement be numbered, or you just need to say that this is acknowledgement? When 1 is received, if it is correct, you will send acknowledgement. That received, you will let us say right received. If it is not correct, if it is incorrect, then you will not do anything. Whenever 2 is received, if 2 is correct, then deliver XYZ to network layer and generate an acknowledgement. So again, I'm repeating the question. In case of stop and wait protocol, where maximum at any point of time 1 frame is outstanding, 1 frame is unacknowledged, do I need to give numbers to acknowledgements, or I can just have an acknowledgement and that will be sufficient? Why do you want to give number, Keval? Unmute yourself and tell me.
Because ma'am, we have sent the frame number 1 as we have given the sequence number. Then how we can come to know that this is the acknowledgement of a frame 1?
Because how many frames have you sent?
Only one at a time.
So when I get acknowledgement of that, that will be acknowledgement of that only.
Yes. Got it.
Like if I'm teaching you multiple topics, like if I teach you 3 protocols, and then if I want to ask that which protocol have you understood, then I need to number them. But if I am teaching you just one topic and ask you, is it clear? Then if you say yes, then I know that this yes is meant for this topic only.
Yes, ma'am.
1 is sufficient means Harsh. So channel says that there is no need of numbers. Harsh, 1 is sufficient as in? Everyone, please unmute yourself. Means no need to number. So you are saying that you don't need to number them. However, actually, we need to number them because otherwise in some circumstances there will be some problem. So identify that problem for me. Take half a minute, think over the case that if we don't give numbers to the acknowledgement, what will go wrong? Where will we fail? Or what will be the trouble? Because if there is no trouble, then we don't want to give that. However, we want reliable communication. When I say reliable communication means the data should be delivered correctly, only once, in order, without loss, without duplication. So why should we give numbers to the acknowledgements also? Please think over that. How? Harsh, tell me the situation, that what will happen, when, how, and how will our acknowledgement numbers help us? Give me the situation. Harsh, can you please unmute yourself?
Yes, ma'am.
Yes, tell me now. So let us say we have sent frame number 1 with ABC content. Then?
So, ma'am, basically, like for this, what I thought was that if in bit means if while transferring up of data, if in between there is like any incorrect data or something goes wrong, then like it might be detected.
No, like this. Okay, tell me like this. You have sent ABC, okay? But what you have received is probably AAC. So data is incorrect. Then no acknowledgement is sent. And data or frame is discarded. And after some time, there will be a timeout. Okay. After some time, there will be a timeout. And whenever there is a timeout, it will be sent again. So this time, because it has not received one was dropped. So when it is getting A, B, C correctly this time, then it will accept it. Acknowledgement will be sent. Like acknowledgement is sent and data will be delivered to the network layer. So tell me, what is the problem? Keval? If we do not get an acknowledgement in given time, then if there is no acknowledgement, there is no number, or there is no question of numbers as well, right? Numbers with acknowledgement. So see, why I'm doing this, I could actually tell you very quickly, that would have taken me only 5 minutes. That if I tell you that in Open Wait protocol, we require acknowledgement, we require the sequence number, we require the retransmission time or acknowledgement number, because this. But then I'm not sure whether I would push you to think in the logical direction. So there are two approaches which we can take. One, I present the things and I brief you about the protocols or subject in general. The second, I raise questions. I want you to think, you think over that, and then you answer. But the second approach, of course, as you can understand, is time consuming. So you might need to do some things once in a while in self-study, or probably you will have to go for some extra classes. Because if we take this approach, then it will not be possible to complete the entire syllabus in the given time frame. Then some extra classes may be required. So I'm fine with both the approaches, whichever is comfortable with you. Should we go for approach 1 or approach 2? So some of you are saying that you should go for the second approach. But in that case, you have to be attentive, you will have to think, you will have to give me answers. And be ready for some part in the self-study so that you open the book actually. That is the motivation. And some extra classes. So let us go for it. So now let us think of the situation. Okay. ABC was delivered. ABC was sent. And it was received correctly. ABC was received correctly. So if ABC is received correctly, the acknowledgement is sent and frame is delivered to the network layer. The frame is correct. So it has been delivered to the network layer and you send the acknowledgement. Now let us say, when I say the acknowledgement is sent, okay, before this time, I'll digress for 1 minute and then come back here. I said that we have a retransmission timer. So again, what should be the value of retransmission timer? Should it be dynamic or static? Like, should I say that 10 minutes? Let's send the frame, wait for 10 minutes. If you don't get an acknowledgement within 10 minutes, retransmit. Should it be 1 hour? Should it be 5 minutes? Or that should depend on some other parameter? Should it be static or dynamic? That is the basic question. So dynamic. So which parameter do you think might be affecting the retransmission timer's duration? The duration will be decided by which parameter? Think in this direction. Think again. Continue. So size of data, okay, or previous retransmission channel, okay. So channel, that is true. That is, actually there are many algorithms which will be deciding that how to define the timer's value. So if you had the past experience of multiple retransmissions, then you are going to give the larger value. Otherwise, it might be smaller. But there's to find a detail, like it is a research topic actually. So we are not going to get into that. Currently, we are looking for one very obvious parameter, and I will say that it's propagation delay of the link. Like from A to B, if you need to take 10 milliseconds to reach from A to B, then what should be the minimum value of retransmission timer? Yes, 20, minimum 20 milliseconds, because 10 seconds you will be consuming to deliver the data and 10 seconds will be on the reverse link. So minimum duration should be twice of that. However, actually that should be much larger than that, not just twice, because let us say when you are constructing the frame transmitter, then you are sending the frame, then frame is sent, receiver is detecting that frame, then when receiver is detecting the frame, then receiver will do the checksum calculation, decide whether it is correct or not. If it is correct, then acknowledgement is to be constructed and acknowledgement is to be sent. And if receiver is busy with some other task, then it might be doing it slightly. There will be multiple processing going on. So you cannot say within 0 seconds or it will be doing that. There might be some finite time consuming in the processing, as well as it might be busy at times. So generally, Very vaguely I'm saying this here. There are fine algorithms for that, but we are not getting into details. If 20 is the duration to reach to the destination and come back, that is forward delay plus reverse delay, which is known as RTT. I'm taking the liberty of using this term RTT, which is actually should be used at the transport layer. This is round trip time. Round trip time, the time which you make to the time which you take to make the trip to the destination and come back. So if your RTT is 20 milliseconds, then the transmission timer can be 40 milliseconds, like 20 minimum you will consume on the link, and then some processing delay and some buffer. Because if your transmission timer is too less, if you are saying let us say 21 milliseconds, then what will happen? The acknowledgement might be on the way and you are unnecessarily retransmitting. Acknowledgement might be on the way, but you are triggering unnecessary retransmissions. So that is not desirable. And you should not keep it too long, like we are not keep it 50 milliseconds, because if it is too long, then the acknowledgement is not come. It is not going to come. But unnecessarily we are waiting for the longer duration to attend the required retransmission. That means our efficiency will be compromised. So if it is too less, they have a problem. If it is too long, we have a problem. And that is why this is one of the research areas where they try to fine tune based on the network parameters dynamically available there. Having said that, I'm coming back here. Okay, we are talking about the acknowledgement number. The frame number 1 is sent, it was correct, acknowledgement generated. Now let us say your receiver took time to generate the acknowledgement. The acknowledgement is delayed. Why? Because receiver has taken time. Because receiver was busy with something more crucial. It was busy with something else which demanded the attention more than your process. The acknowledgement is delayed. So meanwhile, there is a possibility that here there will be a timeout. So whenever there is a timeout, then the same frame will be sent again. It will not be delivered to the network layer, but acknowledgement for this will be generated. Because what your transmitter will think, what your receiver will think, that I had already given acknowledgement, but probably acknowledgement was lost, or probably your transmitter has missed it. So now I'm not going to put this data to the network layer again, but let me tell it that yes, I have received it. Okay, so it is sending the acknowledgement. So now the acknowledgement which was delayed, that acknowledgement is, let us say, received now. So what will transmitter think? That everything is fine. So now let me send frame number 2. So it is sending frame number 2. Now frame number 2 is received as XXZ. It is incorrect. So frame is discarded. Your frame is discarded. Okay. And now on the link you have an acknowledgement. This is acknowledgement of the duplicate frame. That acknowledgement is reaching here now. So what will your transmitter think? That I had sent XYZ. I'm getting an acknowledgement of that. So everything is fine. And then your transmitter will send the next frame. That means we are having data loss here. Your transmitter will be sending frame number 3. Let us say TQR. Something like that. So this particular frame has never been delivered. We have a data loss. Do you understand this problem? In case of delayed acknowledgements, our transmitter might be misguided that this has been delivered, while that was not the case. So instead of that, if we are writing the acknowledgement numbers, like we were saying that this is acknowledgement of 1, and now the 1 frame is coming, so we are saying that yes, take acknowledgement of 1. So when acknowledgement of 1 is arriving here, then we are going to stop the timer for frame number 1, and then we'll be sending this. Now when you are getting acknowledgement 1, so you said that okay, yes, you have received acknowledgement of frame 1, fine, but I'm waiting for acknowledgement of 2. So I'm waiting for the acknowledgement of 2. So until it receives the acknowledgement of 2, it will never be transmitting this. It will never be sending frame number 3. And hence will be saved from missing data. So if acknowledgements are also numbered, then there is no confusion, and there is no data loss. Sequence numbers are required so that data is not duplicated. Acknowledgement numbers are required so that data is not lost. So in order to ensure reliability, we require acknowledgements, retransmission timers, transmissions, sequence numbers, acknowledgement numbers. Once you have this much, then our communication will be successful. When I say successful means whatever we have sent will be received correctly in order, and if it was not received, we will be able to send it again and differentiate also that it is the required data. Are we all together? Okay, then probably you can tell me what should be the length of the sequence number. Like sequence number, we said that you are sending only one frame at a time here. You are never sending more than one frames. Okay, so we want as less number of bits possible in the sequence number, because you know that is not our data which we want to send. This is the extra data which is used to help our transmission successfully. So for assistance, we are never going to, like if you can do with 10 bits, you're not going to keep 11 bits. If you can do with 3 bits, you're not going to keep 4 bits. So I can say that keep the sequence number of 1000 bits and it will work. It will, but that is not efficient. So in sequence number, how many bits do you think should be required for stop and wait protocol, where maximum one frame is pending? Yes, 1 bit is sufficient. Again, that is true. 1 bit is sufficient, because when I say sequence number is 1 bit, I say sequence number is either 0 or 1. That means whenever we are sending our data, then we are sending 0, then 1, then 0, and then 1. So this is our first frame. This is our second frame. This is our third frame, and so on. So at any point of time, there is confusion. The second frame will be confused, then it will be confused either with the previous frame or with the next frame. It will never happen that second will be confused with the fourth one, because only these two, acknowledgement of this or the sequence number of this, there will be scope of confusion between these two only, or this two only. If this two is successful, then you don't need to worry about that. Either this number is different from the previous in the next frame. So if you are sending frame number 1, you want acknowledgement of frame number 1. Whether it is this 0 or this 0, that is not acceptable to us. So because this one sequence number is successfully helping us to differentiate between the previous frame and the next frame, it's sufficient. So we're going to use 1 bit sequence number stop and wait scenario. And the efficiency of stop and wait scenario is never more than 50%. Because half the time you're waiting for the acknowledgement. Maximum half the time you're utilizing the resources. You're sending a frame. So half the time frame is traveling in the forward link. Then for half the time, 50% of the time, you're waiting for the acknowledgement. So maximum efficiency in stop and wait is 50%. If there are more retransmissions, then it will be even lesser. Now, okay, let me again ask you if this is okay so far. Then we are going to start with the next segment. Others, everyone? Do we have any doubt? Okay. So we are assuming that we have this header file available with us. In this header file, various functions are implemented. So whenever you want, you can readily take help of these functions. These functions are already there. We are going to write a program for transmitter, and we are going to write one program for receiver. So this is uniqueness of the Tenenbaum. Tenenbaum was the first person who had introduced student community with the programs of stop and wait protocol, go back protocol, and select repeat protocols, which are actually used in the real life. So of course, these are not the actual problem with minute details, but this is kind of pseudocode, which should be giving you a fair idea about how it will be implemented. And this is much more appealing to us as computer engineers. So these programs are not exactly used in the real life. However, this gives us outline of what would be there. So in this header file, we have wait for an event. So whenever you don't have to do anything, you are waiting for something to take place, then wait for an event will be called. Like at the transmitter, After you send the frame, we will call function wait from frame. Wait for event, wait for event. So event will be returned. If the returned event is timeout, then we know that acknowledgement is not come and there is a timeout. Then you will be going for the transmission module. If the event is frame arrival, because acknowledgement has come, then the event will be frame arrival. Then accordingly you will be taking the action. So at the transmit after sending the frame, we will execute wait for event. Either the event will be frame arrival, means acknowledgement, or the event will be timeout. Now from network layer, packet will be read. To network layer, packet will be delivered. From physical layer, frame will be read, and to physical layer, frame will be delivered. So let us say this is 1, 2, 3 and 4. Out of this 1, 2, 3, 4 functions, which will be used at the transmitter? The question is, at the transmitter, which out of these 4 functions, 1, 2, 3 or 4 will be useful? What do you do at the transmitter? Yes, that is true, Smith. 1 and 4. You will get data from the network layer. You will receive a packet. Then we will construct a frame. And then we will pass it to the physical layer. So 1 and 4 in that order will be executed at the transmitter. From the network layer, disk given, frame is constructed and it is sent to the physical layer. What about receiver? In which order at the receiver we are going to execute that? Yes, 3 and 2. Well done. We are going to first get data from the network layer. From physical layer, we are going to read the frame. Then we are going to remove the header and trailer. In the remaining part, we are going to deliver to the network layer, which is a packet. So now, after sending the frame, at the transmitter, we are starting the timer. We are sending only one frame. But if you are sending multiple frames, for each frame, timer will be started. So here sequence number is associated with the timer. When you receive the acknowledgement, then timer will be stopped. This two is skipping at the moment. Afterwards, we'll do it. And now at the data link layer, whenever you have sent one frame in data link layer, you don't want your network layer to generate more data for you. Then you can execute disable network layer. So network layer will be disabled for the moment and it will keep data to itself. It will not pass on data to us. Whenever you want to read from the network layer, then you are going to execute enable network layer. And here sequence number is 1. Maximum sequence number will be defined as 1 because we are having 1-bit sequence number 0 and 1. So increment k. If it is less than 1, that means if it is 0, then it will be incremented to 1. If it is 1, that means it is not less than 1, then it will be 0. So this increment k is helping us to toggle between 0 1 in case of stop and wait toggle. And this is the frame structure. In the frame, we are having kind. Which kind of frame is that? Is it a data frame or acknowledgement? Or this is negative acknowledgement, which I'll discuss in the next class. Which kind of frame is that? What is the sequence number? What is the acknowledgement number? And information part or data which we received from the network layer. So that is how we are going to construct the frame. So it will be something like this. From network layer, we have read a packet. Then we will construct this frame, and this frame will be passed on to the physical layer. So if there is no doubt so far, we can end the class. In the next class, we'll start from the negative acknowledgement and then the programs for transmitter and receiver of stop and wait. So are we good so far? Okay, thank you.